What's up, everybody? Video for Friday, congruence and similarity with triangles. So I made two videos. If you haven't watched the other one yet, the other one's to get you ready for the mastery test. This one is to help you with the activities or the GeoGebra stuff within it. Now you're going to be looking at three big things here. Okay, even though there's four activities, there's three main things. There's triangle congruence, which means the triangles are all corresponding parts. Then there's how do similar triangles' perimeters match up? And then finally, how do similar triangles' areas match up? So those are the three main topics that are going to get hit in your tutorial. I also talk about those in the mastery test review. So this first kind of GeoGebra activity is on slide 6. I think there's like every 3 or 4 slides, there's an activity. So with this one, the directions are pretty simple to follow. And so it says like draw AC, and then you're going to be finding some angle measures. So here's what it first looks like when you click on it. So the first thing they ask us to do is to draw a line from A to C. We can just draw that segment right in by clicking A to C. They then ask us to find the measure of angle A. So we use our measure angle tool right here from C to A to B. So I know that angle is 35 degrees. They then want us to recreate another angle up above this 35. So I use my angle with a given size tool here. All right. Now, when I hover over that, it says select leg point and vertex. So I'm going to have to select my leg point. I don't want a 45-degree angle. I have my leg point, and then I want 35. Let me see if I can. For some reason, it's already doing that. Maybe that's leg point and vertex. There we go. 35 degrees. Okay, so there we go. So now what you see is it's made that 35-degree angle, and if I were to connect a straight line from A to B prime, all right, that would be making that 35-degree angle. So let's do that. Let's make a line. So I'm going to make a line. I'm going to click on A, and I'm going to click on B. So now what I've done is I've created a triangle above that is congruent to the triangle below. How do I know that they're congruent? Well, since this is 90, I know that this angle right here is 90. This is called a reflexive side, a side that they share. It's the same length in both triangles. And then I have 35-degree angles here. So this is ASA, angle side angle. So these two triangles are congruent via angle side angle. Now let's put a point in right there. Okay. And then what's going to happen, guys, in the rest of the activity, so I walked you through kind of the hard part or the part that might be confusing. You might have to find some other measurements and whatnot, but just follow the directions. But the main purpose here is we just created two congruent triangles. All right, and again, because of ASA. On the next activity, you'll click on it, and it'll look like this. So congruence, proven relationships. Now, I think they may ask you to do some transformations. Don't worry about the transformations. The big thing that we want to be able to do is how can I tell that this triangle is congruent to this triangle? Well, they obviously have some different orientation, but I should be able to tell the sides that are corresponding just by looking at them. For example, the shortest side in the triangle blue should correspond to the shortest side in triangle green. So let's actually find the lengths of these. So I click on my measuring tool, I click on distance to length, A to B, it's 5, F to G, also 5. So I know that both of those sides are the same length. Now let's keep doing that for all three sides. So that means then my longest side, which looks like it's AC, that should correspond to the longest side of my green, which is HF, which is also 15. Now I could test the length of this third side to see if they're the same. And if I have three sides that are congruent in each one, that's SSS, side, side, side. Or I could find the included angle. So if I wanted to find the angle between the two sides that I know, I went in the wrong direction. Let's go backwards. Go from C to A to B, G to F to H. So notice those two angles are the same. So it's true, these two triangles are congruent. Now I chose to do SAS. You could have done side, side, side by just finding the lengths of BC and HG. All right. But if they ask you to do some transformations, I don't feel like you need to do that because I'm going to have you try to map it. The biggest thing is to know minimal information. So notice I didn't have to find this angle or this angle or these angles because I'm taking the shortest route possible. But because I know the blue is congruent to green via SAS, I know that angle C has the same measure as angle H, so they're corresponding angles. It's the angle where the medium and the long side are meeting. Medium and long side, medium and long side. All right? So that is kind of the second congruence one. The third activity you go through is area. Now this one can be a little tricky. Let me see if I can find the area slide really quick here. All right, here it is. So it's on slide 17. So slide 17 will give you this. So the first thing they ask us to do is to find the length of these three sides. Okay, so it says find the lengths of these three sides and then also find the area. Now, let's first find the lengths. So distance from A to C, C to B, B to A. They then ask us to find the area. Now, area of a triangle formula is 1/2 base times height. Okay, 1/2 base times height. Now, hopefully we know that from previous information that if I want to find the area of a triangle, the base has to be perpendicular to the height. Now, if it's a right triangle like this one is, this could be my base and this could be my height. So I would do 1/2 times 7.2 times 3. Luckily, there is a little tool here called area. So all you got to do, click on this, click on the area that you want, ba-boom. Okay, so I know the area of ABC is 10.8. So you would take those four pieces of information, type them in right here. But the next thing they want us to do is they want us to dilate by a scale factor of 2. Now, when I go back to this activity, all right, remember dilation, that would be this. This is our transformation one. I want to dilate from a point. So in order to dilate from a point, I got to first plot the point, remember? So I'm going to plot a point at 0, 0, because that's where we're always dilating from. Now that I have that point, I'm going to dilate from a point. So it says select the object, select the center point. So I'm going to select here. It's going to ask me how much I want to dilate by. So scale factor of 2. So I just dilated that triangle by a scale factor of 2. Now because I'm dilating, that means all my sides have gotten bigger because my scale factor was greater than 1. So notice the difference here. Let's do a distance. Now AC originally was 7.2. So if I scale factor at 2, how much should this be? It's double the amount. So my side length doubled in length. Now, if I find the area of this, it's not double. So I want to just show you that. So area, right? So 10.8 times 2, that should be 21.16. But notice the area is 43.2. So what happened from here to here? Well, that's because when we do area, the difference is the ratio squared. All right, so what I mean by that is if our ratio right here is 2/1, because I'm doubling, the scale factor is 2 or 2/1, I'm doubling the length, that quadruples it. So it's the ratio squared. So guys, I talk about that in the mastery test notes. All right, but that's also referred on, like if you click on this next slide right here, so slide 18, that's going to give you that information. Okay, that whatever the scale factor is, you square that to get the ratio of the areas. All right. So you'll go through the rest of the activity, noticing that the sides double, but the area quadruples because 2 squared is 4. If it was 3, if our scale factor was 3, okay, so for example, let's go backwards here a little bit. Let's get rid of some of this information. All right, let's dilate by 3. Oops, I got a point of dilation, cancel, backwards, so here, and then the point of dilation's here, 3. Look how big that is. Okay, now let's find the area of that. 97.2. That's because since our scale factor is 3 over 1, 3 over 1 is 9. 3 over 1 squared is 9. So 10.8 times 9 is what gave me this. So whatever your scale factor is, you have to square it to get your area ratios. Which leads us to our final activity, which starts talking about perimeter. Okay, so the first thing they ask you to do in this one is find the perimeter of this triangle, which can easily be done by using your distance lengths. Okay, and then if I want to dilate this, I'm going to add my point in. Let's do a dilation. Now if I looked at the perimeter of this triangle, what you'll find is because I'm dilating by a scale factor of 2, that means that all of my side lengths doubled, which means my perimeter doubles. So perimeter ratio is equal to the scale factor ratio. Scale factor ratio squared equals the area ratio. And again, guys, I hit on those as well in the mastery test review, but it's always good to talk about it in the moment as well. All right. So you've got making congruent triangles, checking if they're congruent, area ratios of similar triangles, perimeter ratios of similar triangles. All right. So those are the 4 activities within the tutorial cover. Please let me know if you have any